A customer can choose the train color on the letter which appears on the front. To show the normal operation of the RFT, a customer places an order through the web HMI for a single blue train, which consists of 2 blue parts. After the order is placed from the HMI, the train specifications are sent to the middleware server as a SOAP attachment. After the middleware server validates the incoming file against the event file schema, it is relayed to the Control Workflow Manager via a TCP/IP connection. The Control Workflow Manager attempts to match the parameters in the event file to a predefined action. If the action is found, an invocation list consisting of module calls is sent back to the middleware server. Using the invocation list given by the CWM, it queries the database for the module's location. Then it proceeds to gather the input parameters from the event file and stores it in an internal XML document. Next, the middleware sends the order information to the fulfillment checker function. The module checks the inventory levels in the ASRS. If the inventory levels are below the requirements for the order, an error event is generated back through the middleware, which then terminates the order and notifies the HMI. If there are enough parts available for the current order, a generic acknowledgement is sent to the middleware server. The order information is sent to the order placement module. The order placement module generates an order ID and writes the request in the database. The order ID is sent back to the middleware server. Next, the inventory checker examines the remaining inventory. If the level is below a predefined threshold, the module sends an event to the middleware server, which relays the condition to the HMI. The Automated Storage and Retrieval System, or ASRS, is located at Morgan State University, or MSU, in Baltimore, Maryland. The ASRS contains the new parts for the system. On the placement of a train order, the part locations are determined by a part ordering software module. Next, the SLC requests the supply cell controller to retrieve the train parts from the specific ASRS location. The supply cell HMI displays the status as 2 parts are transferred from the MSU conveyor to the U of M testbed. The parts retrieved from the ASRS travel along the conveyor to the next pallet stop, which is equivalent to the first pallet stop at the U of M RFT testbed. They are manually unloaded from the MSU conveyor and placed onto pallets on the U of M conveyor. As the parts are removed from the MSU conveyor, they are introduced to the U of M testbed. Each part is loaded onto an RFID tagged pallet, and both the part and pallet tags are read before being released. Due to the different RFID tag orientations, they are read multiple times before being released to ensure accuracy. There is a part tracking module which keeps track of the parts and pallets in both the physical and virtual portions of the testbed. When the parts enter the cell, they are placed into the machines by the robot. After machining is complete, they are placed on empty pallets and exit the cell. Before entering cell 2, they are read by another RFID reader. This information is used to determine the next machining operation. completed parts exit the cell and are placed on the AGV. These two parts are sent directly to the assembly cell. Also, the loading of the parts is simulated in the virtual environment. Each part is read by an RFID antenna to get the part information. Each part is then loaded to a specific location on the shelves based on the information stored on the tag. When the cell receives an assembly command, the two parts are mated together to form a completed train. This is the assembled train.